Alrighty. So thanks everybody again for joining our first AnVIL Demos today. Today we have Stephen Mosher presenting an introduction to AnVIL. I'll turn it over to you, Stephen.
Thank you, Natalie. Are you all hearing me clearly enough? And can you see what the screen I'm sharing? Also, wonderful. Super excited to hear this. And welcome to AnVIL Demos. So in the past, we've had AnVIL office hours and allowed people to come in and ask questions. I think one of the awesome things that can help, with a lot of folks is getting a view into some of the things that are going on in the world of AnVIL and within the communities doing their work on AnVIL. So I think that this will help get people's minds moving in terms of the things that can be done and some of the problems that AnVIL attempts to solve. So today, I will be happy to present to you a welcome to the AnVIL slide deck about all the things about AnVIL. But this can only, in a 30-minute spot, only touch the surface of what can be done on AnVIL. So there will be a number of upcoming monthly demos that will be on the fourth Thursdays of each month, and we'll hear about using pangenomes on AnVIL, warp pipelines and workflows on AnVIL, and how to access multiple workspaces, use data across multiple workspaces in AnVIL. So welcome to AnVIL. Let's get started. This slide deck is, you are free to adapt this and share this work. I think there's a comment about needing to cite. Thank you for that. And today, the learning objectives of what I'd hope that we can get across here today are: why is AnVIL in existence? Why is it created? What is it used for? What does it do? And what are the use cases that people are using it for, and how to get started? So let's dive right in. Why AnVIL? One thing that we know is that some 20 years ago, the first sequencings were happening. The first human genome being sequenced used Sanger sequencing using warehouses full of these instrumentations. And it was a quite long and laborious process. And over time, in the last decade, in the 2010s, some technological advances helped increase the volume of sequence data that is available to researchers. And this was catapulted forward with the development of genome analyzers that allowed for sequencing by synthesis and allowing for massively or very parallel, high throughput parallel sequencing. And this really did drive a lot of create a lot of potential for moving forward. Today in the 2020s, we've got new workhorses like the Illumina NovaSeq that can sequence entire populations within months, as opposed to years or decades at what would be required previously. So today, not only is the throughput gone up substantially, the prices have come down also absolutely substantially. So this has created a scenario where there's tons of data to work with, but it's caused a problem. How do we analyze all this data? In the early days, institutional clusters were almost exclusively used for genomics. In the 2010s, the early clouds were put together, and I think a lot of this was really inspirational by the fact that one can provision the amount of compute necessary for a project when it's needed, and then scale it down when you don't. It's very enticing, given that the need for compute changes across the life of a project. In the 2020s, we are now working to develop platforms like the AnVIL. And these are aimed to help revolutionize how we do genomics by creating highly scalable cloud environments that are easy to use. So it's designed with broader needs in mind, such as proper data security and compatibility among other resources in the cloud. AnVIL is attempting to bring researchers to the data by inverting the model for genomic data science. Instead of sending data out in copies that are very difficult to secure and come with siloed compute, we're looking to bring researchers to the data. So the data and the compute can be in the cloud. Simply, the user needs to access the compute and the data with a web browser. So there's an opportunity here to reduce redundancy and cost, improve security, give greater accessibility, and then have this wonderful elastic compute where you can scale up thousands of cores and scale it down when your analysis is complete. So AnVIL offers many compelling features that encourage analysts to migrate their analysis. These include secure cloud environments, access to high-value data sets, strong collaboration tools, the ability to pay as you go for cutting-edge computing technologies, and more. You can learn about all of this or much of it, in a series of videos that we have put together on YouTube called AnVIL in 2 minutes. We know that you're all very busy, so these videos are designed to be bite-sized chunks to help you get a taste or a sense of the things that can be done on AnVIL. So this is a really great starting point. What is AnVIL? There's a lot of ways that we can answer this question. And maybe there's 3 answers, maybe there's many answers, but one way that we can start diving into this is looking at the 3 aspects of what AnVIL attempts to provide for users, the solutions that it attempts to provide for users. And that includes data, compute, and a user community. So the first one, data. This is perhaps the most important, or perhaps very persuasive, as AnVIL hosts many high-value data sets that are full of human genomic data. So that includes various data sets like CCDG, GTEx, and eMERGE, as well as the new human genome assemblies like the telomere to telomere consortium and the Human Pan-Genome Reference Consortium. Not only that, AnVIL is a key player in the NCPI world, or NIH Cloud Platform Interoperability effort, where AnVIL exists as one of many peer platforms. And one thing that AnVIL is working towards as a founding member of this NCPI effort is building technologies and protocols to be able to access data from peer platforms while in the AnVIL platform. So this interoperability will create a scenario where you can learn the AnVIL platform, but gain access to the data and the wealth of information that is also available on peer platforms like Biodata Catalyst, Kids First, CRDC, Cancer Research Data Commons, and NCBI's SRA. So the compute is also a really great offering that the AnVIL provides its users. And this allows access to a growing collection of tools such as Jupyter, RStudio, Bioconductor, and Galaxy. And again, they're all available through your web browser. Additionally, customized software environments can be configured through the use of Docker and Conda. And additionally, important omics tools like GATK, Seeker, Genome Browser, and HAL will allow for some very scalable analysis and allow for some really important discoveries to be made on the AnVIL platform. Last but not least, the users and the user community, I think, are one of the really great offerings and great advantages to the AnVIL platform. So there's a growing community, and it's perhaps one of the, again, a key strength of the platform. So the NHGRI cooperative agreement for the AnVIL platform is between the Johns Hopkins University and the Broad Institute of MIT and Harvard. Together, these 2 awards, along with their sub-awards, bring together developers over 12 academic institutions. And there's super active involvement by the Bioconductor team, the Terra team, the Galaxy team, the core teams that are bringing these resources to you and making them available in the cloud so that you don't have to. So, and again, finally, working with groups like NCPI, as well as GDSCN, or the Genomic Data Science Community Network, and VADSTI, the Virtual Applied Data Science Training Institute, are working to bring a focus and development of features that will increase accessibility across diverse audiences, such as those that are not traditionally engaged in genomics research. So that's kind of why AnVIL is built, but more specifically, what is it and what can we do with it? Let's dive in a little bit more here. So AnVIL is all about cloud computing. Cloud computing, hopefully you know, is powering many of the services that we've come to rely on these days in our everyday world, and powers some of the services like Gmail or the cloud that we use to back up our photos from our smartphone. Netflix allows us to watch videos, and much of this is built on three of the biggest cloud service providers: Microsoft Azure, GCP, Google Cloud, and Amazon Web Services. Today, AnVIL is on Google Cloud, and there is active migration today into Azure. So AnVIL is built on and relies on the Terra platform, and the Terra platform can be thought of as an orchestrator of cloud resources. And again, Terra does this orchestration so that you don't have to. Importantly, it's worth noticing that AnVIL and Terra charge no pass-through costs. So what you pay for is only the resources that you acquire and you provision and use on the cloud. So whatever GCP or Azure charges is what you'll get charged for using the AnVIL platform. So again, AnVIL and Terra collects no pass-through charges. And again, today we're on Google Cloud Platform with a very active migration to Azure. So multi-cloud offerings are in the works. The interface to the cloud environments on AnVIL happen through what is known as the Workspace. And the Workspace is a concrete unit that allows you to provision, to access data, perform analyses, and share. This is the central location that users will come and use the AnVIL and Terra platform. And you can maybe think of this as a dedicated folder for some of the work that you're doing. Workspaces allow you and your team to access and organize data. There's a tab that allows you to launch interactive analyses. So before I had mentioned access to Jupyter, RStudio, and Bioconductor, Galaxy. All of this will happen here through the Analyses tab. Running again, Jupyter is really a great way to interleave some code and text to create some compelling narratives of some of the work that's being done. Galaxy offers a graphical user interface and thousands of pre-configured workflows and tools. It's highly accessible and reproducible, but the tools do need to be pre-configured. The good thing is that the Galaxy team is doing this for you, and there's already thousands of tools that allow you to get started with a push of a click of a mouse button. Or many clicks, a few clicks, a series of clicks. RStudio allows for feature-rich programming in R, allows for wonderful statistical analysis and machine learning and visualizations. And then Whittle allows for some very scalable, like this is perhaps the most powerful analysis that allows for parallel computing and allows you to get through analysis of thousands of genomes simultaneously in parallel. So there's a few icons we like to use here to describe the different aspects of these different tools that are available to the user, from very routine and precise work that one might do on Jupyter, such as some basic engineering that you see in this pictogram, as well as blasting off out into outer space, maybe to the International Space Station, to do some of the best and most cutting edge science that is available for genomics these days. So how do you do the work? You got to have some data to work with. You can bring your own data, but again, like we said previously, part of the power of AnVIL is the data that's already associated with the platform. So sample level data set level information can be found in the AnVIL dataset catalog. This is exposed on the AnVIL project portal, so anvilproject.org. And here you can identify the different data sets and see at a project level how much or what is available. You can also identify what controlled access, what is controlled access and what is public access through this data set catalog. Importantly, it's worth noting that controlled access data requires authorization from dbGaP and consortium data or a consortium data coordination center, or perhaps having data shared to you by the dataset owner. And while you're organizing your data and designing your analysis and building up your workspace, it is by default private. Other people cannot see your work and how you are planning your analyses until you are ready to share them with your teams. Once you're ready to share, your team can come and join you on your workspace, use your data set, the architecture you've built up in arranging your data, pulling in workflows that you've made available in notebooks that you've created or are pulled in from elsewhere, and you can use those to share them with your colleagues. So what are the use cases that people are using? How are people doing this work? Let's take a minute or two to explore some of these. The first one that I'd like to touch on is GATK. GATK is the Genome Analysis Toolkit that is, I suppose, main function is put together to identify variants across genomes and genomic data sets. And AnVIL and Terra is the preferred platform for GATK. Additionally, AnVIL powers large consortium analysis projects, such as the telomere-to-telomere consortium. And importantly, in this new world where NIH has mandated thoughtful way of preparing for data management and sharing in a project, AnVIL is now an approved place for storing your genomic data, and as well as your non-genomic data as well, your biomedically relevant biological data. And so storing your data in the AnVIL platform will help you satisfy the new NIH data management and sharing policy requirements. I mentioned on this briefly earlier, one additional way that AnVIL is helping the community and driving forward is diversifying the genomic data science community. So this genomic GDSCN, or Genomic Data Science Community Network, is comprised of faculty and researchers with affiliations at community colleges, historically Black colleges and universities, Hispanic serving institutions, and tribal colleges and universities. And these individuals are working to educate those that are not traditionally associated with genomics research. One of the key offerings of AnVIL is the ability to create access to resources that perhaps traditionally have been only accessible to those at R1 research universities. This way, we can provide computational facilities to all with access to a Google identity and some data. You can start getting in and doing some very serious amount of compute and discovery in a short amount of time. So that's a few things about why AnVIL was created, what AnVIL is, and some of the ways that people are using the AnVIL. How about for you? How can you get started? If you're new to the platform and you're looking to get involved, I think that perhaps the first place that you might want to go to learn more is the AnVIL Project's homepage, anvilproject.org. There is tremendous amount of information here in terms of what data is available, the types of tools that can be used, and how to get involved. Additionally, I mentioned previously that there are a number of videos that the team has pulled together called AnVIL in 2 minutes. These are available. You can find these on anvilproject.org, or you can go directly to YouTube, and if you search AnVIL Project, these should pop up quite easily. There are a number of these. I think that maybe there's 10 or more of these by now, and there's quite a playlist. So do browse these. There's some really interesting and good information in bite-sized chunks. There's also a number of books that have been written that are freely available. So these are ebooks and can be accessed on your browser. So one of these is called Getting Started on AnVIL, but that's not the only one. There's a collection of guides, including an AnVIL instructor guide. So how can you use AnVIL in your classroom? How can you use AnVIL to pull in SRA data? How can you use AnVIL for urban genomics? There's a lot of thoughts and great ideas that the team have put together in these works. And then, of course, there's a lot of activities and events that are going on in the AnVIL outreach world. So we look forward to seeing you in maybe AnVIL's workshop in VADSD, the Virtual Applied Data Science Training Institute, which will happen on April 5th and 6th. We've also got some links here for Whittle 101. There's some recordings. This is a training that took place, I think, in September and October of last year, but it's very new and recent and very applicable today. So the recordings are available as well as the materials, so you can do this at your own pace, at your own time. I mentioned, and Natalie mentioned as well, that there'll be monthly AnVIL demos where we've listed out the next 3, but these will continue on through the rest of the year. So please keep checking back for more. There's a lot to learn here. And then there's a bunch of conferences coming up this summer that will have many different, that have different ways that you can get involved with the AnVIL community. One of them is additionally perhaps this exciting opportunity, which is the Galaxy Community Conference, which is taking place in Brisbane in Australia this year between July 10th and 16th. So there's another opportunity to get involved for those that are looking for some international experience as well. So with that, what kind of questions do you have? We're happy to discuss here, and we've also got a forum for discussing some of the aspects of troubles you might face or questions you might be working through on help.anvilproject.org. So this is a really wonderful place to come and see what are other people up against, what are the issues that people are facing. Somebody found in this example an issue with cloning a workspace and gave instructions on how they got around a problem. This problem has since been fixed and is no longer an issue, but the point is, sometimes there are people doing very active work and you might find some answers to what you might be looking for here on help.anvilproject.org. Additionally, if you don't find what you're looking for, this is a great place to post. The AnVIL outreach team, Terra teams, and so forth are eagerly waiting to see what you're interested to learn about and questions you have. So please join us in the conversation at help.anvilproject.org. And so let's wrap this up. What did we learn today? AnVIL is brought into existence to invert the model for genomic data science so that you can come to the cloud for your data access and data analysis needs. AnVIL is a place for storing your data, performing your compute, and collaborating with fellow users. Some of the use cases include GATK, telomere to telomere, DMS's data management and sharing policy by NIH, as well as the Genomic Data Science Community Network. Getting started, you can visit at anvilproject.org, as well as a number of the resources that the AnVIL outreach team has made available for the community. I'd like to highlight all of the great people who have helped put this together and would like to stop talking now and see what kind of questions you might have. Thank you so much.
Thank you so much, Stephen.